Okay, now we're going to do an example looking at polynomials of degree at most 2. And here's my candidate, H. And we're going to eventually see whether or not H is a subspace of V. Okay, pause and copy if you haven't done so already. Before we get started, let's do a preliminary question to get a firm grip on what these sets are. Okay, if you don't understand what the two sets are, then you are kind of in a dark room with no light switch. Okay. Is this in V? Yeah, it's a polynomial of degree at most 2. Okay, so this is true. Is this just the number 0? Is that in V? Well, yes, it is. It's you can think of it as being 0 plus 0t plus 0 t squared. That is a polynomial of degree at most 2. Okay, how about 4 plus t cubed? No, that is not, because the degree is too high. The degree here is 3, but my cap is at 2. Okay, 7t squared, is that an H? Is it one of these guys? That's what I'm asking. To be an H, you got to be one of these guys for some choice of the value B. Well, yeah, here I've just chosen B to be 0, so that works. B is 0. This one's false because you have this problem here. Okay, to see that this is false, just ask yourself, is this item here, is it one of these dudes? And the answer is no. Okay, B has to be a real number. It can't involve a variable. Well, this can't be B. Okay, I can't say B is equal to this, okay, because the presence of the T. Okay, is 5 in H? No, it is not. No, it is not. 5 is not an H because, again, 5 is not one of these guys. You may say, oh, well, yeah, let me say that again. 5 is not one of these guys. Okay, to be in H, you got to be 7t squared plus something. Okay, and the only fiddling you can do is here. Okay, you cannot mess with this over here. Okay, the only flexibility you have is there. Is 5 in V? Yeah, 5 is just a 5 is equal to 5 plus 0t plus 0t squared. Okay, so 5 is indeed a polynomial of degree at most 2. And this last one is true as well, okay, because this 7t squared plus b, okay, b is pi in this case. Okay, now let's answer our main question. Is H a subspace of V? Okay, H is a subset of V, since if you take any of these dudes, 7t squared plus b, okay, you can write that as 0 plus, write that as b plus 0t plus 7t squared. Okay, now that I've rewritten it that way, I can see that it's clearly a polynomial of degree at most 2. A is the 0 vector in H. Okay, let's see first of all, what is the 0 vector in the land of polynomials? In P2, the 0 vector is 0 plus 0t plus 0t squared. Maybe I want to call it the 0 polynomial. But this isn't. Isn't an H. So that's a negative, but it's actually making me happy because my question is answered. Okay, to be a subspace, you have to pass all tests. As soon as one of them fails, as soon as you fail one of them, you're done. Therefore, H is not a subspace. Not a subspace of V. You should always write this thing at the end. Okay, you should always say, you should never just write H is not a subspace. You should say it's not a subspace of something. Okay, so it failed one of the 3 tests, so it fails overall. Okay, let's do something with matrices. M 2 by 2. And H is equal to the 2 by 2 matrices that pass this test here. Okay, so we're going to fix this matrix X. So I'm not going to tell you what it is, and you're going to see I don't have to. So X is some fixed 2 by 2 matrix. And we use that to define our set H. This equation tells us, in English, you could say the word is commutes with X. So that's the term that says A and X, you can switch the order when multiplying. As we've seen, that's not always true. But what we're saying is that H consists of those 2 by 2 matrices that actually commute with X. And we're going to see it doesn't matter what X is. We're just imagining it to be some fixed 2 by 2 matrix. Okay. So here's my question. Is H a subspace of V? Question mark. Okay, H is a subset of V. It only consists of 2 by 2 matrices. Okay, that's all we need to know to put this check mark here. So let's go through ABC. 0 vector. Okay, the 0 vector in this case, is the 2 by 2 zero matrix. So here's is this in H? Okay, so I look at the zero vector in V, and which happens to be this guy, and I ask, is that in H? Well, how do you determine if something is in H or not? Well, you have to come back to this defining equation. So we'll say yes. So what's this equation? I have to say 0 vector times x is, well, what is that? Well, that's just 0 vector, right? Okay, when I write 0 vector here, okay, what I mean is this 2 by 2 zero matrix. And then the 0 vector, that's the same thing as x times the 0 vector, right? You can check. Doesn't matter what x is. That's it, right? I have, with this little equation here, I have demonstrated that this matrix passes this test up here. So I'm done. Woo-hoo. B, closure under addition. Let's say don't want to use A and B. Let's say let B and C be an H. Okay, so I need to show B plus C is an H. So refining further, I have to show that B plus C passes the defining equation for H. Okay, remember it was A x has to equal x A, right? So let's prove that. So to do my proof, I'm going to start with my left-hand side and calculate with a positive attitude and hopefully end up here. Okay, you can distribute. I guess well, no, you're not. You know how matrices work. I can distribute, right? Now, I want to end up here. Well, I'm going to have to use this. What does it tell me? It tells me that bx is equal to xb and cx is equal to xc. So let's underline that. So I know. Okay, B and C are in H. B and C are in H. Therefore, B and C pass this test. So I can write down these two equations, and I'm going to have to use them. I'm going to use them right now. This is getting a bit crazy here, but I think it's okay still. Okay, so bx can be replaced with xb, and cx can be replaced with xc. And then I am happy. Okay, so that's B, part B. Part C, I want you to do this as an exercise. Try this. You're going to be, you may be uncertain if you are doing it right. That is totally normal at this stage. So, don't be shy. Send me send your work to me and I will tell you how it's going.